Good morning, everyone. Can you please confirm if you can hear me? I am asking a poll question, so please answer the poll question. Awesome. I can see that everyone can hear me.
You can give the giveaway, Enoch. You can share the screen and then.
Sure, let me do that. So yesterday we have posted some questions on our social media channels and many of you responded to that. So just to encourage you guys, we want to randomly pick one of the person who has commented the answers and we want to give them a surprise gift. So we have already collected the list of people who participated in the quiz. So we have about 165 people. So to randomly pick a person, I am going to use Google's random number generator. And the way this application works is I give a range. So let's say if I give a range 1 to 200, it's going to randomly select one number. So in our instance, we have 165 people. So we are going to select the final number as 165. And the moment I click on the generate button, a random number will be generated here. And whoever is that person back in the sheet would be our lucky winner. So without any further delay, let's do this. 3, 2, 1, and go. So it is number 114. So let's see who that person is. All right, is Anantapalli Nagalakshman Kumar. Congratulations to you, sir. You are the winner of today's quiz, and our team will get in touch with you and they will give you your surprise gift. And once again, congratulations, Mr. Lakshman Kumar. And even today, we are going to post the quiz questions after the session, and the winner would be picked in tomorrow morning session. And thank you so much, and over to you, Barney.
Okay, thank you. Congratulations, Lakshman. Great job. I really appreciate people who are contributing and who are learning in the due process and who are motivating the other people. There will be a lot of people who are not self-motivated. So if other people are posting, other people are winning, then you will also someday probably get to the motivation zone is our hope. Yeah, that's our hope. Okay, anyways. So, yep, I think we should get started now. Let me share the screen. And here is a mind map. Oh yeah, Aparna, that's a good thing. So maybe Enoch, you might want to put that for some time. And quickly again, before you all ask me on where the video is, because by now I think it should be very clear on where you'll have the videos. I'm clicking on the sticky note here. Okay, now the winners details will be posted on the sticky note. These are the videos. Of course, the thumbnails are getting created, and yeah, you can get into this, watch. I think today is day whatever. We have 17 videos here. You might want to watch those and reap maximum benefits. Yeah, today and tomorrow, and then next week. I think it'll be for. Let me see. It'll be for 2 days, right?
Today
We
is
start.
day 18, Barney.
Sorry. Yeah.
Today is day 18.
Day
So,
18. Okay.
yeah.
19, 20. Yeah. Day 18 or day 17? Which day is today, people? Okay. Check. 17. Today is day 17. And 18, 19, 20. So by 28th, we are going to complete this. And after today's session and maybe tomorrow's session, the last 2 days we are going to discuss about all the emerging technologies or emerging algorithms in the space of deep learning, and we will not have time to actually do hands-on. That would not be there, but nevertheless we'll touch upon each and every new algorithm which is bringing in ground shaking results. Okay, that's very important. And here, needless to say, we have also started NLP, natural language processing free session. I'm sure people who have subscribed would have received emails. If you have subscribed to our channel, you would have received emails. And one more thing is, we are also going to conduct free Python programming session. And when is it going to start? I think it is going to start on 3rd of July. It will go on until 7th of July. Of course, I won't be the trainer. We have pool of other trainers. They are as experienced as what I am, but since I happen to be also the director of the firm, I need to focus on the business aspects. So, yeah, there'll be good faculty. Do not worry about that. Who will be training you? But you will be notified on 3 grounds. One is if you subscribe when we do YouTube live, you'll receive. But that way, what happens is only 5 minutes before, or when we make YouTube live, only then you will be notified. So you might not have sufficient time to quickly join. But nevertheless, you can always watch that recorded video because it will be there on your email. Okay. Second, towards the end today, what we will do is we are going to share with you all our Facebook and LinkedIn pages and a few groups. Please follow. The moment you do that, any such free sessions, you will be notified. 100% you will be notified. We don't conduct such sessions in silos. Okay, we broadcast it to the wider audience. And do not miss this because this will set context. Python is being used for IoT programming. It is being used for data science, for AI, for in various scenarios it is being used. So it's the need of the hour. Okay, so make best use of that. Having said that, over to the mind map. As I've promised yesterday, we have updated the mind map with recurrent neural network details that we discussed yesterday. And we discussed about what is text mining, what is natural language processing, what is the disadvantage with the language models, how did we overcome that using MLP, but MLP brings its own challenges. Yeah, then we looked at why we need to use RNN. Okay, what is backpropagation through time, what loss functions are used, what are the variants, RNN CNN models, bidirectional RNN, deep bidirectional RNN, applications of RNN, and when we practically do it, how do you ensure that the data is in a format which your model accepts? For that, we discussed about okay, vectorizing the data. There are 2 prime ways. Okay, segment the data into words, into characters, into n-grams. This process of transforming each word into a vector, each character into a vector, each n-gram into a vector is called as vectorizing. Okay, and the process of getting the tokens is called as tokenization. And we associated each vector with a token, and you can either use one hot encoding or you might want to use token embedding, within which you either do a backprop and update your weights, or you make use of pre-computed or pre-trained word embeddings. For that, we discussed about word2vec and GLOW. We have practically used GLOW. And then we also ventured into LSTM, long short term memory. and we discussed about the various gates that we have. Now, if I were to go to this and get into LSTM here, yep. We also have bidirectional LSTM. We also have deep bidirectional LSTM. But even before that, I think it warrants us to, discuss about the various gates. Question to you all: what is the name given to the various gates? Yeah. What do you mean by remember gate? Which gate is remember gate? Yeah, I'm 100% sure you're going to answer. Come on, guys, please resort to chat window and then let me know. On what are these gates? Yep. Please keep, you know, uh, answering. Please keep your answers going. And what is the select gate? What is select gate and what is the forget gate? Or what is input gate also called as? Input gate is also called as remember gate, right? If you remember, a remember gate is input gate. Okay. And then output gate is also called as select gate. This mind map will help you in this way. And again, this updated mind map will again be uploaded today, end of business, right? And then there are a few things. If I have gate values equivalent to 1, what happens? When gate equal to 0, what happens? You completely forget the contents of corresponding memory elements. When gate value is equal to 1, what happens? Okay. We won't forget anything about the corresponding memory elements. This is your forget gate. Okay, and then remember gate involves 2 steps. It has 2 steps. What are those 2 steps? Step 1 is to determine how much of each of the new value we want to remember. Second thing is remember the gate values. And then what do we do as part of step 2? We add them into the existing contents of memory. Okay, this is what we do. Step 1 and step 2. And then you have a select gate. Select is how much you want to select, basically. Okay. Select from memory. Frame in this way. How much of each element we want to use, right? So this is how you have the gates. You have bidirectional LSTM, deep bidirectional LSTM, and bunch of gates. Okay. And then we have also discussed about how the data flows. We have taken the neuron and then we have looked into that. And then we have also discussed about GRUs. GRU is, I mean, it doesn't need any additional explanation. The reason being, it is extremely similar to LSTM, but the only difference here is that forget and input gates are combined together. Combined into a single gate. That's it. That's all you need to know. So GRU is faster than LSTM. Results of GRU is more or less similar to that of LSTM. Okay, results of GRU is more or less similar to that of LSTM. Simple. And I'm going to share this link with you all. Bookmark and keep it handy. Okay, bookmark and keep the mind map link handy with you all. Just open that, read it. Someone who wants to venture into deep learning and AI religiously, you know, daily we have breakfast, right? We wake up and have breakfast. In that way, read this mind map before breakfast, before lunch, and before dinner 3 times. Like doctor gives you medicines, right? In that way, I'm subscribing this medicine called mind map. You have to take this medicine 3 times a day: morning, afternoon, and evening. That's it. That is all you need. Okay. Also, it will help you in a different way. If you're a kind of person who has sleep issues, if you cannot sleep properly during nights, I request you to have your dinner and then read it once. You'll happily get into sleep. Okay. So see, there are multiple benefits. All right. So that's about GRUs. There is, I think, only one thing that I want to explain about GRUs, and that is the applications. I request you all, if there is any English term that you are not aware of, I request you to just Google search polyphonic music modeling, speech signal modeling, handwriting recognition, robot control, time series prediction, speech recognition, you name it. We have all of these. Okay. And there are many other applications. We will certainly look at a few applications because yesterday I think we weren't able to complete the entire programming part of it. And we need to get into LSTM, long short-term memory. Okay. What did we do in the previous RNN exercise, hands-on exercise? We understood that we cannot take the raw text and supply it directly to your neural network, recurrent neural network. This doesn't work. Hence, what do? We take the raw data and we perform word embeddings on that. Word embeddings on that. And then once you perform word embedding, you get the output. Okay, which will be in vector format. Okay, numerical vector. This numerical vector would be then given as an input to your neural network. And if you observe only this portion, word embeddings and numerical vector, we have looked at word to vec, or there is something called as embeddings within Keras. You can directly use that, or there is something called as glove. We have actually used glove, which is a pre-trained model. This numerical vector is nothing but weights of neural network. Okay, weights of neural network. How do you get that? Either train your data using a neural network, which would learn the weights, but then it would take time because you need to do a back propagation and update the weights. You need to do a back propagation and update the weights. Go forward, calculate the error, come back and update the weights. Keep doing it. Okay, you have to keep doing this. But then this would be time consuming. Hence, we can make use of pre-trained models. In pre-trained models, already this kind of learning was done on huge data sets. So the rigmarole associated with once again training a model is reduced. Okay, that is a advantage here. All right. And there are a lot of other techniques also when it comes to natural language processing, which I'm going to briefly discuss on how to, uh, make your entire processing faster. If you don't want to use neural network, if you have limited amount of data, then obviously proceeding further with neural network will not help. It will not help. So in those kind of scenarios, how do we handle is also something that we're going to discuss today. All right. So simple RNN is not the only recurrent network which is available in Keras or TensorFlow. We also have long short-term memory and we have gated recurrent units. In real world, you use one of these. You seldom use this because it is far simpler to learn the patterns. And one major issue here is, major issue with respect to this is vanishing gradient problem. Okay, we have this vanishing gradient problem. To overcome this problem, people have come up with these two, LSTM and GRU. And here we have a similar kind of exercise. We are going to take the same data set of IMDb. IMDb is a movie database, internet movie database, which has details about a lot of movies as well as the customer reviews written for various movies. Do you know what? Directors and actors, they look at the analysis performed and they look at how was the movie perceived by various people, number one. And taking all the positive things and negative things out of the reviews will help them, direct a new movie in a better manner. If someone says that, you know what, I wish, we had more time given to Chiranjeevi in Saira movie. I wish. If majority of people are writing in that way, they know that okay, in the next movie that we are going to direct, we will take corrective actions. We will ensure that more time is provided to this guy. Right? If it is series of Lord of the Rings, if you have actually, right, multiple parts. From one part to another, they keep looking at the reviews. And if someone says, do you know what? The role of this particular actor should have been more. In the next release, you'll actually see the role of this person slightly more. Right? So do not assume that people are sitting and doing nothing. Movie analytics, films, is a very big space in which people operate. There are startups and companies who just do this. Companies such as Netflix, Hotstar, right, and all these media channels actually make use of this data in a big way, and they hire a lot of data scientists as well. Okay, next. So here you are importing LSTM, embedding, sequential, flatten, and dense. What do we mean by maximum features is equal to 10,000? What do we mean by this? Maximum features is equal to 10,000. What we mean by this is that we are saying that we want only the top 10,000 words, meaning most frequently referred to 10,000 words. And when I say 500, all I'm saying is you'll have different reviews. Review number 1, review 2, review 3, all these movie reviews. If a specific review is exactly 500 of exactly 500 words, it's good, wonderful. If you have 500 words, you have a cutoff, so 500 words. And if you have less than 500 words, then what will you do with the remaining? Yep, people, what do we do with the remaining data? Or for these, missing cells, missing entries, what do you do? Because you're saying maximum length is 500 and you want all these inputs which are provided to your algorithm to be of equal size. Okay, you want all of those to be of equal size. Then what do? You are going to do padding. Okay, you're going to perform padding. Padding means, you can do zero padding, means you'll just extend it. Say there are 300 words. Remaining 200 words will be all zeros. That's called as zero padding. And then if you have another review, which extends beyond. Okay, which extends beyond, then all these will be cut off. So this is how practically your algorithms work. Okay. And then you're saying batch size. By now, I'm pretty sure you all are aware of what is batch size and all that. Okay. And here we are trying to import IMDb dataset. Oops, let me first run this. And here we have IMDb movie review dataset. You're importing the sequence. You're loading the data. You're ensuring that when you load your IMDb dataset, the number of words is equal to 10,000. Most frequently used 10,000 words, only use that. Then you're saying print the length of your input data, print the length of your test data. This didn't come, so let me run it again. So you have 2,500 reviews, movie reviews in your training data. You have another 2,500 reviews in your test data. That is how the data is segregated if you want to use the dataset from Keras. And you're saying samples by time. That's how I want to pad the data. Means you take all the reviews and ensure that all the additional words beyond 500 words are removed. Less than 500 words, you do this padding. Sequence.pad underscore sequences on the training data, but ensure that the maximum length is 500. That's what we have defined. Maximum length is 500. So let me run this. And you're going to run that for your test data also. And then you're going to print the data. Okay, so you have 2,500 reviews and 500 words. And then you're coming up with a sequential model. You're adding an embedding layer wherein you're taking the maximum features and 32. Means what maximum features is? You want only 10,000 words. You want to take each and every word and you want to ensure that each word is represented using a vector size of 32. So each word that you have, say apple, that's the word used. So how do you represent this apple word? Using 32, 1, 2, 3, 4, 5, 6, using 32 different numbers. You do that. And to that, you're going to add another 32 units of LSTM, long short term memory. And that is being connected to another dense layer, which has a single neuron, and activation function is sigmoid. You're going to use sigmoid activation function. Why sigmoid? Because we are taking these IMDb reviews and you want to classify on whether the movie reviews are positive or negative. So it's a two-class problem. When you have a two-class problem that you're dealing with, you need to have a single neuron in the output layer and the activation function should be sigmoid. This part is called as specifying the model or defining the model. You're defining or specifying the model. And then you are compiling the model here. At this point of time, you are compiling the model. When you compile the model, you give an optimizer, which is RMS prop, and you're using loss, which is binary cross entropy, and you're using metric, which is accuracy. Okay, so you compile the model. After you compile, you run the model. And when you run the model, we are giving 10 epochs, batch size as 128, and you're saying out of this training data, set aside 20% of data for validation purpose. So there we go. I'll run it. And let's see how much time is each review taking. So, yep, GPU is being used, but it's still taking a while. And let me see whether everything is okay or not. Yeah. 6%. Now it started using. It's fast, right? It's pretty fast. And then the reason why I'm showing you this is because when we do bidirectional and deep bidirectional, you'll understand that. Yeah. It's going to use more resources. It'll be resource intensive. Approximately 6 seconds per epoch is fairly reasonable, but then the amount of data is hardly anything, right? It's just for the demonstration purpose. Look at that accuracy. Training accuracy is good. Validation accuracy is also good. Okay, of course there is a difference. When you look at training accuracy and validation accuracy, you see that there is a difference of 10%. Okay, 10% difference exists, but that's okay. Okay, now I'm storing the results in this history. Within history, there is another argument called as history. When you say history of accuracy, validation accuracy, loss, validation loss, you're taking all that, you're plotting epochs on the x-axis, accuracy on the y-axis. BO is both circles and line, blue color circles, label, and all that. Same thing, friends. We have been doing this since the initial classes. Same thing is being performed here. Okay, and if you observe this carefully, maybe after fourth epoch, your training accuracy and validation accuracy are getting diverged. So maybe you want to confine your algorithm to only 4 epochs. You can also check your loss. Loss is also, yeah, see, it's very obvious. After the 4th epoch, training loss is reducing, but validation loss is increasing. Hence, you stop at 4th epoch and take it further. This is how we build the models. Okay. Now we will get into advanced use of recurrent neural network. And here, the data set that we are going to use, okay, is a time series data set. Until now, we dealt with text data. See, what we have done is, in the initial algorithm, if you carefully have observed, with rational, then when we started MLP or ANN, we dealt with structured data. Then when it came to unstructured data, because 80% of the data on the planet is unstructured in format. We dealt with images. We have spent significant amount of time on that, and then we have used CNN. Okay. And then there is another unstructured data, which is textual data. Here we started using RNN flavors, wherein we tried RNN, LSTM. There's also something called as GRU, and we are going to look at that also, GRU also. And then in all these, we have bidirectional and we have deep bidirectional. Deep bidirectional. And in CNN, we have looked at building a model right from scratch. So that's called a standalone model. Regular, run of the mill. Next, we have looked at regularization techniques. In terms of dropout and data augmentation, both of those were discussed. Okay. And the third thing that we have discussed here was about using pre-trained models. Okay. And here, when it comes to textual data, we understood on how to use pre-trained models. Okay, that is what we discussed here on how to use pre-trained models. What is that pre-trained model? GLOVE. Okay, and then we are left out with using regularization techniques here, which we will do, obviously. So if you carefully observe, in each and every different data type, we have been discussing about all the various possibilities. For that case, since we had less data, I mean, here in MLP, when we had limited data, how do we handle it? For that, we have looked at k-fold cross-validation. And trust me, all these things that we have learned has covered all the various aspects, all the various use cases. So any data that comes to you, you will be able to handle and you should be able to handle. Because here, not just textual data, we are also discussing about time series forecasting. Okay, so tomorrow, when you start working, no matter what you do, research or work on competitions, whatever be it, you cannot comment that, no, I cannot handle this data. Every aspect is covered. And this is the reason why a few of you all were saying, we need this, we need that. I'm like, okay, hold on. Because at the end of the day, you'll not have, we want this, we want that. You'll be like, okay, all the aspects are covered. All right. So now we are taking this specific data set, which is temperature data. So you can capture a lot of details such as temperature, pressure, humidity, a lot of data. And then you can use all these and build an econometric model. But here we'll not build an econometric model because that is out of scope. It's part of our advanced data analytics program. Okay. So here we are just going to look at temperature, which was captured every day, daily temperature data. That means once in every 24 hours. And you want to then forecast the temperature for the next day. And if you go look at the mind map, you will look at, you'll be able to appreciate the various data types in which we discussed about cross-sectional data, panel data, time series data, all of that. Okay. Textual data, for that also you can use RNN. For sequence data also you can use a RNN and RNN variants. Okay. So let's do this. So we have a specific data set which has various details. I mean, whatever be the frequency at which it was recorded doesn't matter. We are just going to use that and forecast. So even before we proceed further, I've already downloaded and kept the dataset handy. So I'm going to import this dataset. I'm going to go to this data directory. Then I'm going to go to this file and import that. I'm going to open the file, read whatever is there in the file and close it. In this dataset, wherever you find a new line, you are going to split that and create new lines. And then you have all these lines. All these are various lines of data that you have. That's a very huge data set. Okay. Then you just want to take the first line, and wherever you have this comma, you want to split it. And here is a header. You split in that way. Okay. Line of 0. Sorry, I forgot. Index number 0 will be column names. So these are all the various column names. 14 different parameters like date and time, some temperature in degrees Celsius. I'm not sure what the other things mean. It could be various other parameters such as pressure, atmospheric pressure, right? You'll have humidity, then you'll have wind direction, so on and so forth. Many other things are captured there. You can just take the first line, print the header, print the number of lines. You have 420,000 rows which exist. Number of lines. If you just take the first line, or lines from 1 until the end. So here header will only have the column names. 1 until the end will give you all the lines. I can also say that I want only one line, and you can look at this, a single line, right? If I say 1 colon, that means you want all the lines. Okay. And then okay, I can explain this enumerate thing. It's all about one hot encoding. Okay, and giving some names. So let me run that. Why is this throwing in this way? Let me see. Even if this doesn't work, it doesn't matter. So let me show you. Say I'm going to create an object with all these names. Okay, Gopi, Jagan, Sid, Sri. If you say enumerate the names, what does it do? Let's see. Look at that. It's giving, 0 to this, 1 to Jagan, 2 to Sid, 3 to Sri, in that way. This is the application of enumerating. Okay, and I need to certainly figure out on where this error is coming from. So, and then here we have this enumerate. Cannot copy sequence with size 0 to okay, enumerate. I think the previous, somewhere I should have given that code. I haven't given, maybe. Let's see. That's okay. All right, here matplotlib, you want to import pyplot. You want to take the temperature values, all the rows and column 1. Why float data? Because remember, inputs, when you give to your data, it should be in floating point format. Then you plot it. I think there is somewhere there is error going on. If you plot length of temperature and temperature values, it's giving a single line. Then if you go here, it is throwing an error. Mm, X and Y should have the same dimension. Let me see, just give me a minute. Was the dataset not loaded properly is also a point that I need to ponder upon. Let me look at this. Is this dataset available or not? Yep, it's there. Yep, we have the data here. And we are referring to what? Temperature. Okay, which will be, is it 2 by any chance? Let's see. So I'm going to once again import this dataset and let us see on what is going wrong here. Let me load that dataset and read the data. Close the file. So you have the data which is loaded, which is in string format. So you're splitting the lines. You have various lines of data that you have. It's gonna take time, but everything is segregated by a comma. So you are saying, okay, split this header. Not just that, lines also and print it. So in header, yep. Oh no, why is header taking this? Because did I run this twice? Maybe that could be the reason. Now I understood. So let me redo it. I'll run it only once and then it should work well. Yes, that's it. I'll not rerun it. Okay, then you can run the enumerate thing if need be. Now it's going to work well. Now I understand. Okay, so I'm going to plot this. There we go. So when you look at this, you have x-axis values, which are nothing but a range of length of temperatures, all the temperature, various temperature values. How many values do you have in the data set? How many lines do you have? Here it's clear. For 420,000, right? 420,000 rows are there. Hence you have those 420,000 or 4,20,000. And all the temperature values are plotted. It appears like this, and very clearly there is some kind of seasonal effect going on. Up, down kind of, right? It's increasing, decreasing, increasing, decreasing, increasing and decreasing. It's a cyclic pattern. That's called as seasonality. Maybe this is summer season, this is winter season. Winter, summer season, winter season, summer season, winter season, in that way. This kind of analysis is needed for you to understand, right? If you take the temperature for only 10 days, how would it look like? Okay. And here, why are we taking the range as 1440 and temperature is colon 14 for 1440, because you know what, temperature is measured once in every 10 minutes in this data set. Temperature is measured once in every 10 minutes, and in one day you have 24 hours. 10 minutes, 10 minutes, 10 minutes. How many 10 minutes make 1 hour? 6 10 minutes make 1 hour. Okay, this 12, 10 minutes, 10 minutes, 10 minutes, 10 minutes, 10 minutes, and 10 minutes. 1, 2, 3, 4, 5, 6. 6 10 minutes make, this is 12, 10, 20, 30 minutes, 40 minutes, 50 minutes, and then 60 minutes. Okay, so you have 24 hours. So 6 multiplied by 24 will be 144 points per day. Okay, that's one thing. So you plotted entire thing. Whatever comes first, it gets plotted, I think. And then if I take this range, then how many days data would that be? 144 points per day. And if it's 1440, then it is 10 days data, right? 10 days into 144 will be 1440. Let me plot that. This is how it will appear for 10 days if you plot. Okay, so these 10 days is not a good indication because it could be fairly cold winter month. We don't know, right? So I'm just plotting you and showing you the representations. Then what do? We are supposed to normalize or standardize the data, and we are going to use this formula, x minus mean divided by standard deviation. For normalizing or standardizing, we use this. So you say, take all the data until 20,000 rows, and then take the average of it. Axis equal to 0 means for axis equal to 0 will be column here, if I'm not mistaken, right? And then you're taking the mean of each and every column. Then you're taking the data, subtracting it from the mean, and then you're dividing it by the standard deviation. This can be written as float underscore data is equal to float data, whatever data you have, right? All the values minus mean. Instead of writing it in this way, I'm just writing in this way, minus equal to. Then when it comes to standard deviation, you're writing it as float data is equal to float data divided by standard deviation. Done. Then we are formulating the problem. This is very, very important. You have to first formulate the problem in a specific manner, based on the business objectives. So I'll first explain about a few terms, and then we'll take a break, come back, and then solve this. Okay, so the given data has data which is recorded once in every 10 minutes. In the data that we have, it is recorded once in every 10 minutes. So every 10 minutes is called as one time step. And we have many such steps. And you need to predict the temperature, okay, in delay. So what we are doing here is we have 720 observations. If I have if I give 720, that's what we will do. If I give 720 observations, then how many days data would that be? Every day, as I've told you, you'll have 144 data points. Okay, every day. And for 10 days, it'll be 1440. This is nothing but 10 days of data. If I say loopback is equal to 720, what do I mean by that? Look at the last 5 days data. That's what you'll be instructing. And then you'll be giving something called as steps also. But then let me explain delay. Delay, if I say 144, means what? It is 1 day, meaning 24 hours. Though the underlying data that you have is captured for every 10 minutes, you're doing some pre-processing because your end goal is to forecast for every 1 day, every 24 hours. This is your end objective. Forecast the temperature for every day. But the data which is provided to you is for every 10 minutes. So input data is in this way, wherein you have data for every 10 minutes, but you want to forecast for every 24 hours. Hence, you need to do some pre-processing to ensure that this 10 minutes data is converted to once in every 24 hours. And this is exactly what we will do. And this part is called as data pre-processing or preparation. You are preparing the data to meet your objectives. Okay, we'll get there, but then you know for a fact that we will take a break. Let us be back by 11:45 and we'll take this further. Okay, welcome back. So let us proceed further. And what we are going to do now is, instead of pre-processing the entire data, we are just taking top 200,000 time steps as training data. Okay, and we are going to compute the mean and standard deviation only for this amount of data. We are not taking the complete data into consideration. Okay, we are taking only 200,000 observations, and then we are converting that. Now, I mean, we are normalizing the data, because here, when you look at the underlying data, temperature will be of different scale altogether. Okay, and the remaining variables will have a different scale altogether. You'll have all these different values. A few values will be in the range of thousands. Temperature will be probably 10 degrees, 20 degrees. It'll be only 2 digits. A few of the other things will be in, uh, they will have a larger value. Like if you look at, atmospheric pressure, which is here, P, which is measured in M bar, that these values will be around 1000. So we want all these values to be of the same range. So we normalize the data. Here, we are going to again do some kind of generation yielding. So we are taking the data. We are saying how many time steps back the input data should go. If you say look back is equal to, we're going to give some number which will appear at the bottom. So if you say look back equal to, say 720, it's not here. Yeah. So you're going to look back 5 days. Delay is how many time steps in the future the target should be. Okay, for how many time steps you want to forecast. If you want to forecast, say once in every day, then you have to move ahead by 144 time points. Let me explain here that you're taking the data, you're saying look back is 720, delay is 144. By doing this, what you're saying is, you're saying I'm going to go back and take last 5 days data, and I'm going to forecast for the next day. Next day means 24 hours ahead of race. This is how you're preparing your data basically. Minimum index and maximum index is going to define. If you want to go back for the last 5 days, which is a minimum index number and what is a maximum index number. And you're saying shuffle equal to false. Whether to shuffle the samples or should it be drawn in a sequence. Remember, whenever you deal with time series data, you should do sequential split, or the data which is arranged in chronological order. You have to consider only that. You should not be randomly sampling the data. And using batch size, you're saying number of samples per batch. Okay, and steps equal to 6. 6 is if you want to draw one data point every hour. Because here I was saying that this underlying data has 10 minutes. Every 10 minutes data was captured using various sensors. So 10 minutes, 10 minutes, 10 minutes. If you have 10 minutes, it becomes 60 minutes. 60 minutes means 1 hour. So when I say step equal to 6, that is exactly what it is going to do. Okay. This next lines of code is just for your demonstration on, how this generator works. How do you want to shuffle all that? In this way, you want to prepare your data. So I'm giving 1440 as look back, 6 delay is 144, batch size is 128. So that generator function that we have written, user defined function, you're applying that on your data. You're saying look back for 5 days and forecast for the next day. And when you do that, you do it in this range, minimum 0, maximum this much. So this much data would be part of your training data. If you want, you can give a shuffle equal to true, but usually we do not shuffle the data. We want it in sequential order only. Step equal to 6, batch size equal to whatever is the batch size, 128. Okay, so we'll run it. I'm just taking true, but you should not ideally remember that. And then from 200,001, that is 2 lakh 1 until 3 lakhs, you're putting that into validation. And then the remaining data is being put into test. So number of validation steps is given here. Okay, and number of test steps is also given here. Okay. So how many steps to draw from validation data in order to see the entire validation data is given here. And you also have test data here. Okay. Now this is done. Next, how do you want to measure the error? Okay, how do you want to actually measure the error? Basically, that's what we are interested in. Now in this, we are going to use something called as mean absolute error. The advantage with mean absolute error is that after you calculate the error, you can take the average, okay, of all those values. And another advantage is the interpretation. Say your mean absolute error happens to be 0.29, just as an example. Because the temperature has been normalized, how did we normalize it? We ensured that we applied Z transformation, which was X minus mean divided by standard deviation. This is what we have applied where? Here, in this portion. By doing this X minus mean, you are in some sense ensuring that mean becomes 0. And by dividing it, you are ensuring that standard deviation is 1. So that means, since you have standardized in this way, once you calculate the mean absolute error, you cannot readily interpret that. So you're just going to multiply it with the standard deviation. Okay, why? Let me explain now. You are using Z is equal to X minus mean divided by standard deviation. All right. Now by doing this mean absolute error, you're taking each error value and subtracting it from the I mean, you are subtracting these two and then taking the mean of it. So mean is already taken care of. Take care of standard deviation, which implies if you want to get back x value, x is equal to z into standard deviation, or x minus mean is equal to z into standard deviation. The standard deviation is taken on the other side. So x minus mean equal to z into standard deviation. This is in some sense mean, absolute error. So because you're subtracting, and z into standard deviation is something that you're doing here. You're taking that value, whatever you get, and you're multiplying it with the standard deviation of your temperature. Temperature has column index number 1. Whatever number you get here, that number can actually be interpreted. Okay, so this is done. Let us also run this. Okay, it's taking a while, but that's okay. Then what we will do is, after that, we are going to train first densely connected network. Okay, you'll just do a multi-layered perceptron, just to show you on what happens if you try out MLP on sequential data. So you define your model, compile your model, fit your model, and then you visualize the loss and accuracy. Okay, once that is done, you'll understand that the model will be pathetic when you use MLP. So what we shall do is, we have looked at RNN and LSTM, so we shall now switch to GRUs. Look at GRU, it is very, very simple. You just say gated recurrent unit. And when you run this gated recurrent unit on this data, the data the way it was, you'll be able to run GRUs. Okay. Then what we will do is, we are going to add a dropout. When you want to add a dropout, you have to add two attributes. One is called as your dropout, another is called as your recurrent dropout. Already you're familiar with this dropout. What will it do? It is going to randomly make your inputs 0, so that particular, if it makes the 0 or the value which is coming out of the 0, so the input to this will become 0. Okay, the input to this will become 0. This is one thing which we are already aware of. Okay, but how do we apply this to a recurrent network is not a simple question to answer, right? I mean, since long we know that we can apply dropout. Okay, but then we didn't understand on how to apply that for recurrent. So in 2015, a guy has a PhD guy by name Yaren Gull, right? He has actually come up with this dropout for recurrent network. But the only thing is, you have to apply the dropout at every time step. So here dropout would randomly drop out, usually, right? From time step to time step. But here we have a constant time step which we are going to apply throughout. And throughout every time step means this is one time step. This is another time step. This is the third time step. In that way, you have multiple time steps. Okay, so every recurrent layer in Keras has two dropout related arguments. One is your regular dropout. Sorry, 1 second. Sorry about that. Yeah. And then another dropout is called as recurrent dropout, which specifies the dropout rate of the recurrent units. One is, in this dropout, how many neurons should be dropped out? If you say 0.2 and if you have say 5 neurons here, randomly one neuron will be dropped out in this connection. That is one way to handle. In this, right? All these neurons will be connected to all these neurons. But if you say dropout equal to 0.2, randomly out of 5, one neuron will be dropped out. But then when I say recurrent dropout is 0.2, when you say recurrent dropout is 0.2, then randomly 20% of your recurrent units will be dropped out. Say you have say you have 1, 2, 3, 4, 5. Okay. In each pass, randomly one of these units will get dropped out. What is a unit? This is a unit. So how many units do you have? 1 unit, 2 units, 3 unit, 4 and 5. You have 5 RNN units. A simple dropout will drop out only within this RNN, the connections. But when you say recurrent dropout, it is going to drop out one of these randomly. That's the application of this dropout. So the moment you do a dropout, you would observe that your model starts working very well. I mean, the overfitting issue will be resolved to a great extent. And within Gmail, or within Google rather, you have a translate, language translation. If you give data in, or if you give the text in one language, you can translate it into another. Let me show you. So English to French translation. Okay, you type something. It says bonjour, right? So this is how you pronounce this. Hello. But then, which algorithm is being used behind the scenes is a question. So if you give a lengthy text such as, how are you? Immediately it is doing it, right? So it's giving this explanation or translating one language to another. So when it comes to Google, Google Translate uses a stack of 7 layers. Google uses a stack of 7 layers of LSTM. which is a huge thing. Okay, this is one more thing that we are going to learn. So here that is. You're taking one layer and you're adding another GRU layer on top of that. And here you always have to say return underscore sequences is equal to true. Rather than taking only the last layer output or at the last time step, rather than taking the output there, when you say return underscore sequences is equal to true, it will take all the outputs of all the layers rather than only at the last time step. It will take outputs of all the layers. Okay, the moment you do this, once again your model will start improving its performance. Once again the accuracy will improve. And how do I further improve? For that, we are going to use the bidirectional RNN. So what happens in bidirectional RNN? You are very well aware of that. And what happens is RNNs usually are order dependent, the order in which your data occurs. Okay, or you can also say that it is time dependent. They process the time steps of their input sequences in that order only, in that sequence only. Why didn't I define it? We defined right. Took so much time to just tell that something wasn't defined. Spreads. Just give me a minute. Let me look at this. Somewhere the spreads is not defined is what it's saying. If we just run this, is that throwing the error? Just give me a minute. I'm just figuring out on where it's missed. Just give me a minute. I'm figuring out on where did I miss out this bread. It's there here. So let me do one thing. Let me run only this part. Maybe it didn't run properly. That's what I'm sensing. Okay, let it run. And if it doesn't run, I can any day fix it. That's okay. Okay, let it run because here we have threads. Probably didn't read it correctly or define it correctly. That's okay. All right, here these RNNs are extremely dependent on the sequence. the order in which the data appears. Okay, since it depends on the order in which the data appears, we can make use of something called as bidirectional LSTMs or bidirectional GRUs. Let's understand that. So they process the time steps of the sequences in order, shuffling the data or reversing the time steps and completely change the way your model learns. This is the reason why they perform well on problems where order is meaningful, such as your temperature forecasting. If you want to do temperature forecasting, it'll be very good. So bidirectional RNN, what does it do? It exploits this order sensitivity. It's very, very sensitive to order. Hence, what it does is it's going to have two RNNs or two LSTMs or two GRUs. One will process the data in one direction, another which is in chronological sequence, and another RNN or LSTM or GRU will process the data in the reverse sequence. One will process the data in this direction, another will process the data in reverse direction, which is called as anti-chronological sequence. And then you merge this chronological and anti-chronological sequences together. So your unidirectional RNN or CNN or LSTM might capture the data in a specific order, but when you use bidirectional, it is going to capture the data in both the sequences, both the orders. This is the advantage. Okay, if you simply run this, the reverse sequences, it will do exceptionally well. Okay, so this is just evaluating the LSTM in reverse sequence. That's what is mentioned here. Entire data will be printed in the reverse sequence, and you're going to train your model in reverse sequence. And you'll see in the reverse sequence what is accuracy. Then what we shall do is, if we process the data in both the directions, what would happen? It is in some sense similar to something called as ensemble technique. Ensemble technique means you run multiple models. Model 1, you use some technique. Maybe you use something called as decision tree. You'll build another model, model 2, which could be a random forest. Then you combine both these results. Say one model says person will have cancer. Another model says person will not have any cancer. So you are in some sense going to combine these two together. Okay, and then say you built another model, third model, which is some other decision tree. And this also says cancer. So what should be a final output? Majority. Majority says cancer. So the final prediction result will be cancer. That's the logic of ensemble. Your bidirectional models are very, very similar to that. Simple addition of dot bidirectional will do the trick. So what happens is, say you have the data like this. I am happy. Okay. So one RNN or LSTM or GRU processes this data in chronological sequence. It says I am happy. So you'll have the data in some chronological sequence. And in another sequence, it'll be happy am I. So this is the reverse sequence or anti-chronological sequence. Okay, you're going to learn both these sequences. So here also you'll use another RNN model or LSTM model or GRU model. And then what you do is you kind of merge these two together. Merge means you add these two or concatenate these two, and finally you get the data. This is how your bidirectional model works. And you know what? You can also do a bidirectional, not just LSTM, but you can also perform bidirectional GRUs. Here you see GRU, bidirectional. So you have bidirectional GRUs, unidirectional GRUs. You can resort to any of these. But the only thing that you need to bear in mind is it will be extremely, extremely time consuming. 400,000 observations, right? 420,000 if you see here. That's huge data. Hence, it's going to be, challenging. So what did we do? If I were to wrap it up until here, we have taken the time series data. Even before that, we have taken IMDb textual data, and we have run a simple RNN. You can also try out LSTMs and GRUs. But since you have data in textual format, you had to convert that to numerical vector. How did we convert it into numerical vector? By applying word embeddings. Here there is something called as word to vec, but then we have used GRU, which is a pre-trained model. This is one part that we have discussed. Then we have taken time series data, or which is also called as forecasting. And what did we do with that? We have done the data pre-processing. You add the data which was provided to you, wherein data was captured once in every 10 minutes. That's how your input data looks like. But then your output was entirely different. And the output was, the goal was to forecast once in every 24 hours. We were supposed to forecast the temperature one day ahead of time. Okay, then we had to do some data pre-processing to arrange the data to suit this requirement. That's what we have done. The next thing is, once we had the data in the way we wanted, yeah, look at this, it's giving the right result. It's 0.8. Okay, we'll get to this code later. And then what did we do? We have run the regular model. What do you mean by the regular model? We have done the simple RNN. Okay, if you do a simple RNN model or the first recurrent network, even before that, we will run MLP. Okay, I want to show how MLP results will look like. Then I'm going to use a simple RNN or a simple LSTM or a simple GRU. Anything can be chosen. I'll choose GRU just to show you on how the results would be there, would appear. Okay, and then what we will do is we are going to apply regularization techniques. We will do dropout, and we have already discussed about two dropouts. One is your regular dropout, another is your recurrent dropout. Okay, one is your regular dropout, another is your recurrent dropout. One second. Yeah. And then we will see how the results would appear. Then we are going to look at multiple layers together. Here it's a simple one layer. Then we will look at stacked layers, stacking the various layers together. How would the accuracy improve then in this case? After this, we will also do bidirectional. You can run bidirectional RNN, you can run bidirectional LSTM, or you can run bidirectional GRUs. So all these things, I mean, in some sense, we are not leaving even a single option unturned. Right? We are using all the various options available to see which option is going to give us the best results. Okay, so and then we also have one-dimensional, CNN. So all the varieties are covered here. So here, since we have 0.289, which is roughly 0.29, if you multiply it with the standard deviation, you get back the original result. Again, it's saying pred is not defined. It's already defined and calculated. Anyways, that's okay. So now I'm going to run this. First, let me fit this or define and compile the model. Not sure why it's taking so much time just to define and compile. Yeah, it's fast. Now, GPU has to kick off, otherwise it doesn't work. So I'm fitting the model now. This is just your regular MLP. Let us see how much time it takes. We have taken 500 steps per epoch, but that's okay. Otherwise, we cannot compare the results. So let it run. And move on to the next epoch. Let it move to the next epoch. I'm just waiting to see when it's going to move to the next epoch. Not sure why it's taking so much time. Let it move on. If it moves to next epoch, I can at least go back and take your questions. Only the first epoch will take time. From the next epoch round, it'll be faster. Hopefully. See, for such a data set wherein you have 400,000, it's taking so much of time on a GPU machine. Imagine what would happen to your CPUs. And then also imagine if the amount of data is 30 lakhs, 40 lakhs. I mean, usually the amount of data is so large. Okay, let it run. I'm still waiting for this to complete. Is the memory choked? Is a question that I need to look at. Okay, let me see what's going wrong here. CPU 37%, memory is 54%, so all good. All good with respect to Ethernet speed and all that. That's not needed any which ways. This GPU has no role to play. This GPU is 12, 13. It's fluctuating in that range. Maybe the error surface is quite complicated here. Okay, let it complete. While it completes, let me look at your questions. All right. If you don't mind, may I know again what the command predict equal to samples? Yep. Yeah, I mean, you will have to attend the Python programming for that, Shakina. Okay, because it's not as straightforward as it would be. Okay, so you attend the Python programming for this part. Overall logic, if you understand, good enough. Line by line, program by program, not possible at all, because programming is not something which can be learnt overnight, and this explanation needs some better understanding of programming. Then in the recurrent dropouts, if we drop out a time step, the flow will get blocked. Huh. So absolutely you're right. But then only that part is gone. The next part will pick in. For example, your question is, if we have it in this way, and if you're dropping this unit, then what will happen is your question. That's okay. This will directly get connected to this. Only this part, if it's not there, it will learn on only these words, the other words. It's just that you're saying, I am happy with the training. All we're doing is sometimes we are missing out this happy word. That's okay. Not that in every sequence, in every epoch, it's going to miss out only this word happy. Sometimes it will miss out happy, sometimes am, in the next epoch with, in the next epoch training. Yeah. You don't want your model to learn this sequence in such a way that if there is any other sequence, it will not be able to do anything. We don't want such a teaching to happen, right? That's the reason. Okay, that's point to Srinivas. How much time it will take in CPU? It will not even run, Shakina. But is that a valid question? Is something that you have to again ask yourself. Is it i7 processor? Is it i3 processor? Is it i5 processor? Is it a Pentium 4? Is it Pentium 3? How much RAM do you have? Right? Is it NVIDIA processor, or is it you know um, Intel processor? Which one are you talking about, Shakina? Right? So you have to ask those kind of things. Then Srinivas says, and what way we might be missing some data, what we supply. I think that I answered that, right? In bidirectional and unidirectional RNN, which one is good in all aspects? Okay, here also, Sujata, you will have to ask two questions. Which one is faster and which one is accurate? It should always be in tandem. Okay, so you have to look at the speed, which one is faster and which one is more accurate. Always there is that cost benefit analysis that you need to do. If Amazon or Netflix or Big Basket comes to you and says, hey, can you build me a model? Then you cannot say I'm going to use a deep bidirectional GRU because accuracy will be very high. What would you do? You will say, while the accuracy is very high, speed will be very slow when you do bidirectional models. But when you do unidirectional, it'll be much faster. Which one do you want? Is a call that you have to take. Okay. As a good artificial intelligence expert, you have to build solutions which are applicable for business. So that is a question that you need to ask. Yeah, kind of, Usman. Kind of. Then training error versus test error. How much different to accept or reject the model in industrial standards? Okay. So this is again contextual, GVN, extremely contextual. Okay. A couple of things that we need to remember is when you look at training accuracy and when you look at test accuracy, if training accuracy is 90% and this is 89%, is my model overfitting? Or if this is 90% and if this is 80%, is my model overfitting here? In which scenario is it overfitting? For that, what we do is you take all the epochs here, plot your training accuracy and plot your test accuracy. Wherever it diverges, starts diverging. I've shown you in the plots, right? That is where you stop. Simple. You'll not worry about how different it is to claim that it's overfitting or not. You just plot it. Wherever your accuracy values or loss values start diverging, you stop there. This divergence could be after 10% difference, or it could be after 1% difference. Right? So it is again contextual. Hope that answer is also a question is also addressed, GVN. Could you suggest any standard reference, the reason for using RMS prop in regression? Nothing like that, GT. You can use any of your optimizers, which we have discussed. But which one will work very well? Of course, adaptive optimizers. Sorry. So you need to use adaptive optimizers. Where did we discuss about optimizers? I think here. Okay. So these adaptive techniques, which we have, work very well. ADA grad, ADA delta, RMS prop, ADAM. But out of these, which works well? ADAM works well based on my experience. Only based on my experience. If you ask another chief data scientist on which one worked well, maybe majorly they worked in a different industry. In that industry, maybe RMS prop worked well. But why are we using this in regression? We have to use something, so I've used this. You can use this or this or this, doesn't matter. Okay. Usually people resort to grid search techniques wherein you try out all the various combinations and decide which combination is the best. Hope GT that answers your question. Okay. The previous model, LSTM that you trained, are we converting first 500 words of each using 10K words in the format? The model that you trained, are we converting the first 500 words of each review to numbers? Yes, exactly. Using 10,000 top words. Yes. Yep. exactly. So we are training that model and we are trying to predict on whether that particular review is positive or negative, Usman. All right. Oh, still this is playing games. So what we shall now do is, let's wait rather than wait. Anyways, it's break time. So let's take quick break for quick 10:35 exactly. So let us be back by maybe 10:45. Sorry, 12:45. Okay. Let's take a break and come back. By then, I think this should be done. Yep. I think it is taking more than 10 minutes. Yep. To complete each epoch. Yeah, that's your underlying data, Usman. Where are we downloading the data from? Keras, right? IMDb dataset. What do we have in that? Output variable and input variable, right, Usman? Were you paying attention while I was explaining this part? Let me, because that's a very basic thing that you asked. I'm a little uh, taken aback by that question. So here you have IMDb dataset, okay, wherein when you split the data, there are inputs and outputs. Here you have the input data, which is the review. Output says 0 or 1, right? Positive or negative. The same is the case with test data also. You have 25,000 reviews of training data, and for each and every review, is it positive or negative is given. You have 25,000 test data. For each and every review, you are given whether it is positive or negative. Usman, you will have to respond. Very important that you respond. Only then I will be happy. So please respond. If you're not going to respond, I'm going to cry. Okay, so please, please respond. And yep, there is the. I mean, I've just posted the link, Anuradha, of the mind map. Please bookmark it so that you do not lose it. Okay, so let me refresh and see these. Yeah, Usman, these are all okay. I think again you're asking me a question pertaining to machine learning primer. Machine learning primer, you have gone back to data collection. In data collection, you collect the data, you take the reviews. Someone would have read that particular review and classified as positive or negative. Someone would have manually read it automatically. It doesn't fall from the sky, right, Usman? Someone will manually read it and write it, and that's the kind of data that we are taking. Agree? No data will fall from the planet, from heaven, right? It is something that you will get. Okay, you'll have output and you'll have input. Input is nothing but reviews. Output is the sentiment. Someone who would have manually read it, people like Usman, people like Barani would have read it, and then they would have told that, okay, it seems like this is a positive review. And someone would have manually read this review, and they would have told that this is negative. Someone would have read this and told that this is positive. In that way, then what does your machine learning algorithm do? It will learn the patterns, and then it will come up with a mathematical equation. Day 2, if I'm not mistaken, day 2 or even day 1, that is when we would have discussed this part. Day 1 or day 2, I don't quite remember. I need to look at the videos, right? I understand it's been roughly 17 days today, so maybe you don't remember it, but then it learns the patterns. If this word, this word, this word, this word, and this word exist in your review, that would be positive. If this word appears in the review, it would be negative. These kind of patterns are learned by a model. Next time when there is a new review which appears, based on all these previous learnings, your model will analyze this and then classify on whether this is positive or negative. Okay, so I think it's going to take roughly, as our friend has commented, it is taking how much time is it taking? 10 minutes roughly for one epoch. So that means you now understand on what might happen if we try to uh, you know run deep bidirectional networks, etc. Right? It would be super crazy. It will take a lot of time. Of course, this is MLP, right? That's, yep, we are trying out MLP, multi-layered perceptron, hence it's taking time, more time. But then when you run this algorithm on GRUs or LSTM, it might be a touch faster. Okay. Finally, we are going to look at one-dimensional ConvNet, 1D ConvNet. Okay, what happens in 1D ConvNet is you will try to apply convolution neural network ConvNet on your textual data. And what happens is, until now we have discussed about how do I apply this patch on the image. Okay, but then you also have 1D ConvNet, wherein um, if you apply a 1D ConvNet, it will look like this. Say you want to do 4 or 5 or 3, whatever bit. Means it will take 3 pixels, or if you say 5, it will take 5. And then it will take all these 5 and apply on the patches. On these 5, when it applies, you get the central pixel. And then if you move it by one stride at a time, it will move to the next 5 and central pixel, so on and so forth. So rather than applying across, it's applying only in one way. So it'll be much faster than your 2D. And when you look at your underlying data set, when you have text sequence data, sequence of textual data, what do? You take the text and you apply this 1D ConvNet on that. You'll apply this on the text throughout. Okay. And 1D ConvNets, I mean, your textual data is also in this format. This is also in the same format. I mean, you're just taking this and applying it throughout. And 1D ConvNet, um, typically is also called as dilated kernel. Whenever you have audio or whenever you have machine translation, meaning one language to another translation, etc., 1D ConvNets come in very far, very handy, because 1D ConvNet is faster than RNN. Again, if you ask me which one is better, I don't have an answer to that. Not me. Even God will not have answer to that. A few techniques will work well on certain data sets. RNN works well on certain other data sets. Does it make sense to try out both? Yes, absolutely. And then figure out whichever is faster, whichever is giving you better accuracy. So that's how it works. Okay, now. So if I apply the 1D ConvNet on the data, what do you think will happen when you take this and start applying on the text here? The textual data would get reduced in length. Similar to your CNN, you have an input and you have a filter or a kernel or a mask. When you take this and when you apply it on the image, you'll get an output which will be reduced in size. On similar lines, when you apply a 1D coordinate on your data, the output will be reduced in size. Same thing. So even if you look at this, you're loading the data set. You're saying that you also want to import sequence. You're saying that maximum, 10,000 top or top 10,000 words are being used here. Frequently used terms are taken, and for each and every review you're taking 500 words of reviews. Okay, then I'm loading this data set, and when I load this data set, I'm ensuring that I take only the top 10,000 frequently used words, and that data is being split into training and test. Within training you have inputs and output. Within test also you have input and output. If you have only input and output, then your model will learn the patterns between X and Y. Certain reviews might have 200 words, certain reviews might have 1,000 words. If you have 1,000 words, you cut down and take only top 500. If you have only 200 words, then it's not of 500 size. So you'll pad it, you'll zero pad it. Meaning you'll add some, you'll add 300 missing entries. Okay, so you run that. After running that, okay, that this is preparing the data basically. Once you prepare the data here, you know that when you have textual data, you cannot use it as is, so you use embedding. By applying this embedding, you're going to ensure that your textual data is converted into numeric vector. The moment you have the data in numeric format, you use it for you use it as an input to your neural network. Okay, whenever you supply this, you know that input should have and if you're taking 10,000 words, that those 10,000 words will be your input, right? And then you're saying that I want to take all those features, 500 words, and each word should be represented using 128 numbers. Each word, whatever be it, say training, will be represented using a vector of size 128. Then you are adding conv 32 con 1D layers of 7 size. 1, 2, 3, 4, 5, 6, 7. Okay, you're taking all those 7. 32 such with ReLU activation function. Then you're doing a max pooling 1D. Remember, we are not using max pooling 2D. We are using 1D, conv 1D of size 5. It's going to reduce the size. It will start applying on this patch of 5, and it will take the maximum value of all these 5. That's max pooling. Then you're connecting that to conv 1D 32 7. Then you're doing a global max pooling. I will try to explain later on what is the difference between max pooling and global max pooling. And finally, you are connecting it to a dense network. You're flattening it and connecting it to dense network, and then you get the output. Okay, this is how you're building your model. You can run this and complete it. But the good part here is you can run this particular 1D component even on a CPU machine. You need not have a GPU. So you specify your model, you compile your model, and you fit your model. Right. This is what it is. You can also do some kind of uh, um, you know mm, this generator actually does some kind of regularization, right? So you can also apply this regularization technique and then proceed further. Yep. So you can actually combine CNN and RNN also. Right, let me show you if I have it. No, it's not there, but you can combine CNN and RNN and then proceed further when you have long sequences of data. So usually people can use this on textual data also. You can do that, is what I'm saying. So here, until here, if you observe, we are using conv 1D, one dimensional layers. Then what are you doing? You're taking those and connecting it to your RNN model. The RNN model being used here is GRU. And you're also using regularization techniques. There we go. So these are all the various techniques which come into picture. Okay, I think this would endlessly keep running. Anyways, a word of caution, do not run MLP. Okay, let me stop it on your data. Okay, do not run MLP. Let me try out GRU. Let's see how much time this is going to take. Let me open the GPUs and see what's happening. Let's see how much time this is going to take. Same thing, same settings. Okay, but 20 epochs. Come on. So let's wait for this to complete. Okay, fine. So while that completes, let me explain you about stuff that I've missed out. And I've missed out explaining about max pool versus global max pool. Okay. Max pool is fine. When I say global max pool, this is also a max pooling layer, but the only thing is it will be equivalent to the size of the input which is given to this. For example, if you're giving this an input, and usually for images you don't use it. So if for images also you can use it, that's fine. Okay. So if the input which is given to this is 3 by 3, then this global max pool will apply on this entire image. You need not do a max pool of 2 by 2, etc. By default, applies onto entire thing and it will return you a single number. This is equivalent to flatten. It is comparable with something called as flatten layer. Okay, max pool, flatten. Either use this or that. Okay, people try out various things, experiment. The one key thing that I'm going to tell you is experiment. Simple. There is no other silver bullet, no free lunch theorem. Just keep experimenting. Okay, so let me go here. And while that part completes, we can at least do a quick recap. And I'm not going to run the other code, because if this is the case on this GPU machine, then it's going to take a huge amount of time and we don't have so much of time, right, to wait for each and every model to complete. Okay. Next, GRUs we discussed, LSTM we discussed, then 1D component. 1D component is very similar to your 2D component, but the only thing is when you have long sequences like 500 words, etc., RNNs are extremely expensive. You're seeing what's happening now. It's very expensive. Why am I saying expensive? Because time is equivalent to money and it's taking a lot of time. That's why people keep using that term called it is expensive. Also, you need a GPU machine to run. Okay. And since RNN, okay, let me put it here. When we have large sequences of data, then RNN is very costly. Hence, we are going to resort to 1D component. 1D component is cheaper. Okay, it is going to process the data and run your data in a faster manner. So here once again, RNN can be used not just for your textual data. RNN can also be used for handling time series data, which is called as forecasting. When I say RNN, don't confine your thought process only to simple RNN. Simple RNN, LSTM, GRUs, all these are called as RNN models. Okay, you can use 1D ConvNet for various purposes. Let me write the applications here. You can use this 1D ConvNet for machine translation, which is nothing but sequence to sequence models. And then you also have document classification and can be used for spelling. Okay, now since it's taking a while for this algorithm to run, and since we do not want to waste our time, I'm going to walk you guys through something called as functional API. So until now, we discussed about sequential models, which uses sequential APIs, application programming interfaces. Now let me take your attention to functional APIs. Sequential means what? You take your input, supply it to the next layer. It could be conv layer, it could be recurrent neural networks, it could be a simple MLP in that way. So you have input, you supply it, and finally you get your output. And then you have your different models, wherein what if I say that here I'm going to give you input which will be an image. At the same time, I'm going to give you another input, which is going to be description of this image. Like when you look at your Amazon or Flipkart or any of the online portals, you'll have images, you'll have description of those images, and you'll also have reviews, which people write. Okay. Rather than description, I'll say you'll have the details on what is the price of the image. Price of the image, then you'll have the color of the image, you'll have size of the image, so on and so forth. You'll have the image itself, then you'll have the reviews, which is textual in format. And then based on all these three, I want you to predict on what will be the on whether person is going to buy this or not. Will a person purchase this or not? Right? Until now, we have been looking at each of those separately. Can you, by combining all these three, predict your output, whether people will purchase or not? How do you go about this, right? You cannot obviously use a sequential API. It will not work. And this is where people resort to functional API. What happens in functional API is you will have option to use multi-input model. So what you'll do is you'll take this regular data, which is structured data. Okay. I'm going to call this as metadata. Price, color, size, so on and so forth. You supply this to your MLP, multi-layered perceptron, or ANN, artificial neural network. Next, you take the reviews. Okay, you take all the reviews and supply it to your RNN model. Then take your image that you have and supply it to your CNN model. All at one go, okay? Multi-input model, all these inputs. Then you merge all of these together and you'll have another module to merge. That's called as merging module. Finally, you will have the output, which is will a person purchase this or not. This will help you improve your website. Okay, because it's not just the price, it's not just the color, it's not just the size, it's not just the image that is there on the website, it's not just the reviews, it's combination of these which will trigger a customer to purchase your product or not purchase your product. On similar lines, you can also have a multi-output model. This is multi-input model. You'll have something called as multi-output model. What do you mean by multi-output? These are all advanced models, okay? Second thing is multi-output model. The project that we have done a few years back for a company in USA which is specialized in educational loan. Okay, they had a challenge wherein they were saying that, do you know what, when students apply for the loan, they apply for the loan for the very first time. So we want you to, use some other data alongside their application data. I mean, they fill the loan application form. Alongside that, we want you to use something else. Then we thought, all right, let us extract the data from social media. And we extracted the data. Once you extract the data from social media, you can do two things. On one side, you can predict the emotion of the person, whether the emotion was positive or negative or neutral or joyous or sad. Those kind of emotions can be extracted. And on another side, you can also, based on the kind of comments that that person is doing, you can in some sense um, get some kind of numbers on approximately how much money that person spends on various gadgets or whatever be it. Okay, spent. If there is a student who is a spendthrift, who keeps on spending on iPhone, MacBook, and the latest of the gadgets, then it's really difficult, right? So here on one side it is categorical, and on another side it is numerical. Both of these are predicted at one go. Okay, and multi-output, multi-input. You're taking multiple inputs to get one single output. These are all your inputs. Okay, and you get an output here. Here you have a single input and you're getting multiple outputs. Okay, and a lot of networks which are developed of late require you to have non-linear network topology. These are the networks which are structured as something called as DAGs. DAGs stands for directed acyclic graphs. For example, Google has come up with something called as inception. These are all part of your pre-trained models. Okay, here in inception, your inputs which are given, if it is an image, it is processed through multiple parallel convolutional branches. You'll have parallel convnets, one convnet, another convnet, the third convnet, fourth. All these things will be running in parallel. And once you get all these outputs, you merge all those outputs to get a final output. And of late, people, I mean, because Google has come up with Inception, Microsoft thought, okay, we are sitting idle, let us do something. And Microsoft has came up with something called as residual nets, which is called as ResNet. Okay, this is how it is. Okay, you also have residual net. Okay, I can give you quickly the diagram of the same. So in Inception module, what happens is you'll have an input. You take that input and supply it to 4 convolution layers. 1, 2, 3, 4. This is a typical Inception module. This is how it was. So supply it to this, supply to this, supply to this, and supply to this. 4 inputs, okay? And next, they have put 3 different conv layers. This will go here, this will go here, this will go here. Next, they have given 1 comment. And finally, you combine them. Combine the output which comes from here, from here, from here, and from here. Combine all of these. And then you get an output, final output. This is your typical Inception module. Then you have residual connection also. How does that work? If this is your input layer, you connect the output to another layer. You connect that to another layer, connect this to another layer. If you keep doing this way, what happens is maybe the information which your model learned here becomes important for you at this stage. So you're going to take the extracts from here and then add it here. You take your extracts here and add it here. So this is a slight detour from our, so you're taking whatever is left. That's why it's called as residual. Some residual which is left out here. You're taking it and putting it in the downstream flow of data here. So this and this, both of them go here. Similar to your RNN, but RNN you do it after every RNN unit, but here you do it in this way. Okay, so we are going to run these kind of models. Okay, and we will see how it works. And yep, I'm going to show you the architecture code. I'm not going to run it because if I give images, textual data, and the regular data, everything as an input, it will take its own sweet time. Just for text data, see, it's still taking time. Now imagine I doing all those variants for you and showing. It will take, you know, extensive amount of time. Anyway, so these are a few things that we had to understand. Now let me look at questions if you have any. Yeah. What Cambridge Analytica? Cambridge Analytica was it into education loans, Sasanka? Right? Cambridge Analytica was a company which was extracting the data from Facebook. Our job was to extract the data for education loan. Okay, let me look at your questions. Yep. Muthukrishnan has a question. Is this nonlinear network topology is internally used in Spark? You can use it. You can use it, Muthukrishnan. But let's not divert our people. RDDs are the format in which data is read into some big data processing tool called as Spark. Okay, just ignore that, friends, for now. All right. Sure. I think we are good. If you want to read, uh, if you want to get notified on the NLP and free R and Python programming, all you need to do is subscribe to our channel. Once again, I repeat, we have free Python training coming up. So if you click on subscribe, you will be able to watch that. You'll be able to attend. Just click on the subscribe. Okay, this is one thing. And YouTube live, but it will come to you 10 minutes before the session starts. Maybe you will miss out on that, who knows. So for that reason, we also have we also will be posting on our LinkedIn and Facebook. So if you're there, you'll get access to that. All right, attendance link is posted here. Please give your attendance, please fill it. Okay, and the mind map, please bookmark so that you get it. Okay, Jaban says we have been defining, compiling, fitting the model and plotting them to check for the accuracy, but we haven't seen real output. Can you please show? Real output will be the output whether, how do you check, Jaban? Tell me. Model dot evaluate and give in your brackets the data. That's it, test data. We have done it, Jaban. I think you didn't focus or didn't give attention. For every model, I didn't do it, but we have already done it for MLP. The same thing can be done, right? It's just one line, model.evaluate. That's it. All right, Jaban. Is a residual example what you have shown the data chunk, what we are bypassing anyhow will pass on to that layer. Yes, exactly, Srinivas. But parallelly, you'll be running all the models and then combining it. What we are. Yeah, but it will get diluted, right? Srinivas, it will get diluted. So you're taking it back again. Mind maps will be available for the rest of your life, Uma Devi. You'll have it for the rest of your life. So no worries. Yeah. Have a good day. Tomorrow we'll connect. We'll talk about a few more interesting things. Okay. Yep. Thank you all, guys. Have a good day. Bye. That's a mind map. Enjoy. Bookmark and then make best use of that. Thank you all.